The first step is to identify what the actual objective is. So I am going to highlight this sentence that says, how many trays of each type of muffin should the baker make to maximize his profit? Not all of these problems are the same, but what you should recognize in all of them is that there is a question somewhere. So somewhere in the word problem, there is some sort of statement that's posed to you, and then there's a question right after it. Here it is in this one. It's not necessarily the last sentence. It happens to be on this one, and it definitely is on your Go Formative because I mimicked the two so that you could hopefully do them together. But it is not necessarily the last sentence. That's telling you what you're finding. So we are trying to solve this. We are trying to say how many trays of each type of muffin the baker should make. That is the objective. So I'm just going to write that down quick. For what is the objective? To determine how many trays of each type of muffin to make. And I'm just going to draw an arrow from that sentence I highlighted to right there. Another key part of this sentence is identifying your objectives. Can you guys all put your Chromebooks away, please? You should all be paying attention up here. Okay, so within that sentence, what is missing? Like, what is the objective and what are you trying to find to answer the problem? So I'm going to tell you in this one, you're missing how many trays of each muffin type. That's what you are trying to find. So that's your variable. That's your missing information, because variables are always the unknown. You're usually using X and Y and you're solving for them. So the unknown is going to be somewhere in the objective sentence every time. I'm going to label X for this problem as trays of corn muffins, and I'll use Y for trays of bran muffins. You can use any variable you want. You could use C for corn, B for bran if you want. I just always use X and Y. I think that most math problems use X and Y. I feel like it's just common, so that's what you see me use. You guys can use whatever. So number of trays of corn muffins for X. And for Y, we're going to do number of trays of bran muffins. And again, I found that right from that objective sentence or the question that's posed to you. Within that question, you're clearly missing the type of trays or the type of muffin, how many you need to make. Besides from these two missing pieces of information, there's other data within this problem. I would say the other information that's brought forward to us is cups of milk and cups of wheat flour. So I'm just going to jot those down as other constraints, or I'll just list it as other. I'll do cups of milk and cups of wheat flour. Okay, for this first problem, we're taking notes in class, obviously. So we're taking down like all the parts and pieces to putting this problem together. We're going to use what I just wrote down in step 1, which obviously is not any type of answer for the problem, but we're going to use all that information to answer part 2, which says write the constraints and the objective function. So you need to write all of those inequalities that you have previously been given. If we come back up to the word problem, it says baking a tray of corn muffins takes 4 cups of milk and 3 cups of wheat flour. I'm going to highlight everything that discusses cups of milk in pink and everything that discusses cups of wheat flour in orange. The next sentence states that baking a tray of bran muffins takes 2 cups of milk. Oops. So we'll highlight that in pink. And it takes 3 cups of wheat flour. Highlight that in orange. A baker has 16 cups of milk and 15 cups of wheat flour. So the reason why I just highlighted all of those things was to categorize. So everything that talks about milk is highlighted in pink. That's going to be my first constraint. So when I write that, let's take a look at just the pink highlighted sections. And let's write an inequality. We're going to start by saying 4 times x. That's 4 cups of milk. X represents trays of corn muffins. So 4 cups of milk per tray of corn muffins, times however many trays. Plus 2 times y, which is 2 cups of milk per tray of bran muffins. We have a total of 16 cups of milk, which means this here has to add up to 16 or less. We don't have more than that. So I'm going to use an inequality sign of less than or equal to 16. So if you look at the numbers, up here, everything I highlighted in pink was 4 cups, 2 cups, and a total of 16 cups. I kept all of those together for one of the constraints. Next, I'm going to do what I highlighted in orange. So 3 cups of wheat flour per tray of corn muffins, that would be 3x, plus 3 cups of wheat flour per tray of bran muffins, or 3y. This has to be 15 or less, so we're going to use less than or equal to 15. We have 2 other constraints. We have to specifically focus on just our variables x and y. Can you ever bake a negative number of trays of corn muffins? Does that even make sense to ask? No, I see a lot of you shaking your head no. No, you can't make negative muffins. That literally makes no sense at all. So x represents trays of corn muffins. X has to be greater than or equal to 0 for that reason, because you can't make negative number of trays of corn muffins. You could make 0, none, but not negative. And for trays of bran muffins, can we make negative trays of bran muffins? No. So we also have to define y as greater than or equal to 0. Those don't happen every time, but a lot of times they do. So you do have to pay attention to what you're working with and make sure you define all variables and write all constraints. These here are the 4 constraints that you'll be graphing. Lastly, we need to write our objective function. So the objective function is the only function that has an equal sign when you are writing your equations or whatever you're doing. Yeah.
How could the x and y be equal if greater than or equal to 0? Like, how can they be equal to 0 if you can't make 0 muffins?
You could make 0 muffins. You just make none. Okay, so the objective function, let's see. This sentence right here talks about how much money he makes. So when we first went over the vocab for linear programming, I told you the objective function is usually something to do with cost or profit. In this case, we're talking about profit. To write the objective function, I am going to write it as the profit is determined by he makes $3 per tray of corn muffins, so 3 times x for corn muffins, plus $2 profit per tray of bran muffins, so 2 times y. And this is your objective function. Next, we need to graph our constraints. We need to identify our vertices and test our objective function. I'm going to start with my first constraint, which I wrote out in pink, so we'll graph that in pink. So in standard form, we have 4x plus 2y is equal to 16. Could someone tell me what the x-intercept would be for this problem? You can just shout it out if you want. Anyone? The x-intercept? The x-intercept would be 4. So I'm going to plot a point at 4. The y-intercept, what's that? Anyone? It's 8. Yeah. All right, so we have our x and y-intercept graphed for the first equation. I'm going to connect these points. And I'm going to note to myself that I'm shading below this line. I'll do that after, but I know I'm going to be shading under. I'm going to include 0, 0. For the next inequality, we have 3x plus 3y is less than or equal to 15. As an equation, that would be 3x plus 3y is equal to 15. What is my x-intercept on this one? Yeah. 5. Plot a point at 5. How about my y-intercept? Also 5. I think I misgraphed a point. 1, 2, 3, 4, 5, 6, 7. I misgraphed this point. Hold on 1 second. I counted wrong. Right? All right, sorry about that. I just counted on my graph wrong. So anyways, here we go. That's the equations we have graphed so far. Next, we need to graph x is greater than 0, which is this line here. It's the y-axis. And y is greater than 0, which is your x-axis. And then we shade our feasible region, which is below this orange line, below the pink line, above the x-axis, and to the right of the y-axis to give us this feasible region. To identify my vertices, I have this point. I'm going to label them. I know we don't have to, but just for explaining, we have a point at 0, 0. We have another vertice at 4, 0. Make sure you don't mix up your x and y values. It's easy to do, but pay close attention. Right here we have an intersection point at 3, 2. And here we have an intersection point at 0, 5. We'll come down to the table. At this point, this is just one of the problems we've been doing. So we need to write down our vertices. 0, 0, 4, 0, 3, 2, and 0, 5. And then we need to write down, yeah, go ahead. We need to write down our objective function and evaluate that. Our objective function that we wrote was 3x plus 2y. When I evaluate this, my first vertice at 0, 0 will just be 3 times 0 plus 2 times 0, or 0. Next up, we have 3 times 4 plus 2 times 0, which is equal to 12 plus 0, or 12. Three comma 2 is evaluated to 3 times 3 plus 2 times 2. That is equal to 9 plus 4, which is 13. And lastly, 0, 5. 3 times 0 plus 2 times 5, or 0 plus 10 is equal to 10. So we're looking for the baker to make maximum profit. We don't care about the minimum profit. Our maximum profit is $13. So the reason, or the way we read this, is $13 for the max profit. It happens at an x value of 3. Your x value represents trays of corn muffins, and a y value of 2, which represents trays of bread muffins. So when you answer these word problems, you need to answer them in context. Please, don't go overboard. I'm a math teacher, so I don't need you to write me a paragraph. I mean, feel free if you want to, but I'm not checking that. One sentence is fine. Just make sure it includes all of the information. So I would say something simple. I would say something like, the baker makes a maximum profit of $13 when he bakes 3 trays of corn muffins and 2 trays of bran muffins. That's it. That's all I would say. And I'll write that down.